Number 6 from our module 10 CYU says, given tangent of theta is equal to negative 0.47 and that secant is negative, we're going to answer a few questions about this particular situation. So the first question is just the angle theta, its terminal ray, what quadrant would it fall into? And we've done a few questions like this. So if we're thinking this through, let's keep in mind, so tangent is negative, and if we remember, it's going to be negative when that terminal ray's slope is negative. So we're looking at something in either quadrant 2 or quadrant 4. But then we're also told that secant is negative, and secant is the reciprocal of cosine. So it's equal to 1 over cosine of theta. And we know that cosine represents our horizontal distance from the vertical axis, and that's going to be negative to the left of our vertical axis, which is in quadrants 2 and 3. So they both overlap in, so to make both of these statements true, we would need to be in quadrant 2. And that's important when we go and find the angle measure, because we need to sort of make sure we're using the right terms. So now we want to find the value of theta between 0 and 2 pi. So we're told that tangent of theta equals negative 0.47. So we're going to use inverse tangent since we know the slope and we're looking for the angle measure. And if I put that into my calculator, I would come out with negative 0.439 radians. But keep in mind, that's not the angle I'm looking for. Remember, we just said that we're looking for an angle that falls in quadrant 2 here. But if we think about it, we just came up with an angle measure that's in quadrant 4. So we're going to need to use some of our knowledge, and I'm going to just sort of erase this and redraw my drawing. We're going to need to use some of our knowledge of reference angles, because the angle measure we were given would be basically this angle right here, and we need to figure out this angle, this other one. Well, that both of those angles put together would be equal to pi. And so if I do pi minus that 0.439, I'm going to come up with the angle measure theta that I'm looking for. And so I end up with 2.702 radians. And yes, I do need an answer in radians because it does say I'm looking for the answer between 0 and 2 pi, which implies that my value should be in radians. Now, next up, I'm asked to find the value of sine and cosine. We're going to use the angle measure we just came up with. So we would have sine of 2.702 and then cosine of 2.702. And both of these, I would just put them straight in my calculator. Cosine comes out as a negative 0.905. It's negative. That's good because secant is negative. So check, it met that requirement. And then sine comes out as a positive 0.425. Sine should be positive in quadrant 2, so I like that value as well. Last but not least, it wants us to construct a unit circle. So we're going to test our circle drawing abilities. It's a sketch. So there's my circle. And I'm asked to label theta and the endpoint of the arc formed. So, we have that angle of 2.70. So, I'm going to draw, and I'm going to try and make this a little nicer looking than my previous drawing. So this right here, that would be angle theta. And then the endpoint would be our coordinate point. Remember, cosine represents our x coordinate on the unit circle, and sine represents our y coordinate. And ta-da! Finish the first problem. The next question, number 7, is going to be pretty similar, but we're given some different information to start with, and then basically asked to do similar sort of thought process with these. So we're told that sine of theta this time is the negative 0.75, and cotangent is positive. So then we're asked, will secant be positive or negative? Well, let's remember that secant is equal to 1 over cosine. So we need to think about whether cosine would be positive or negative given the situation that we're looking at. So I always go back to my little diagrams. So we know that sine is negative. Sine represents a vertical distance from that horizontal axis. And so that's going to be negative in quadrants 3 and 4. But we're also told that cotangent is positive. Well, cotangent is going to be positive where our terminal ray has a positive slope. Well, that's in quadrants 1 and quadrants 3. So we notice that they overlap here in quadrant 3. Well, in quadrant 3, cosine is negative. Therefore, secant of theta will be negative. All right, so we know that we end up with an angle in quadrant 3. So when we go through and use our inverse sine here, we need to keep in mind that we're going to be getting out an angle measure in quadrant 4, but that's not actually the value that we're looking for. We got to use some of our reference angles to figure out the real measure. So we get negative 0.848. That would be this angle right here. But I want this angle over here. Now remember, that sort of measure right here should match the angle between our horizontal axis and the terminal ray. And so if I do pi plus 0.848, I'm going to wind up with my correct angle measure, which rounds to about 3.990. Next, we're just, putting in our angle. And the nice thing about this next problem, so when I'm looking for cosine of 3.99, this is my check, did I do everything right? So cosine should come out negative, and it does, negative 0.661. And then tangent, which is the reciprocal of cotangent, should come out positive, and it does, with a 1.134. Last but not least, we're going to draw a picture just like we did on the previous problem. So here is my unit circle. This time we're in quadrant 3. There is my theta. And then the ordered pair of negative 0.661, comma, negative 0.75. Ta-da! All right, moving along. So the previous questions have focused a lot on interpreting and sort of understanding of the relationship between, the angle measures and the outputs of our trig functions. We're going to shift a little gears here. We're going to do some simplifying with our other trig functions, and then on to some solving of equations. So here, basically, our goal is to simplify these. They should simplify down to a single trig expression. Remember, simplified makes it better. Step 1, typically you want to rewrite in terms of sine and cosine. So here, secant would be 1 over cosine of x. And then cotangent would be cosine of x over sine of x. You might want to keep in mind as you're working, you might want to have, those identities we talked about in our exploration written out so that you sort of have them in front of you as you work. Cosine over cosine reduces to 1. So I'm left with 1 over sine of x, which is the same thing as cosecant of x. All right, next one, we got a division problem coming up here. So we have secant, so 1 over cosine of x divided by cosecant, which is 1 over sine of x. And since I'm dividing by a fraction, if we remember, that's the same thing as multiplying by the reciprocal. So I'm going to flip my fraction, and I end up with sine of x over cosine of x, which is really just equal to tangent of x. All right, last but not least, we have cotangent times tangent, all divided by cosecant. Now, I could change this into sine over cosine, but there's an important thing to remember here in the numerator. Cotangent is really just equal to 1 over tangent. And if that's being multiplied with tangent of x, what's going to happen here in this numerator is that those are just going to cancel out to 1. And then in the denominator, I got my cosecant of x, which is the same thing as 1 over sine of x. So I really have here 1 over sine of x. Well, that's basically saying I have the reciprocal of cosecant. Well, the reciprocal of cosecant is sine of x. So all of these were just sort of some practice, getting those down to single trig expressions. We're going to work more with then incorporating that into other and more challenging problems in the next module. But the other thing we want to practice is solving some basic equations here. Now, with all of these equations, I would strongly recommend that you check your answers in the graphing calculator. I'm not going to show that out here, but it's always a great idea to graph and make sure that the answers in the calculator are matching the answers that you're coming up with algebraically. All right, so goal 1, we want to get that tangent of x on sort of its own. So we're going to multiply both sides by 3, and so we get tangent of x equals 12. I need to figure out the angle measure. That's going to get me a slope of 12, so I'm going to use inverse tangent of 12, and I come up with 1.488. Now, thinking about tangent here, remember, that particular angle would be in quadrant 1. We're looking for its pair in quadrant 3, which would be pi further along because it's 1 period later. So if I add pi to this, I'm going to get my second answer of 4.629. So our two solutions, 1.488 and 4.629. Part B here is going to be a little different because we got that 2x in there. So remember, with a frequency there, we're actually going to end up with 4 solutions. We're going to end up with double the number of solutions because basically you think of it as the rays move in twice as fast. It does 2 rotations in the time it takes others to do 1. Still going to treat it the same way. I want to get tangent sort of alone so I can undo the tangent using inverse. So I have tangent of 2x equals negative 12. And so, oops, nope, I multiplied. I should not have multiplied there. I needed to divide. That's a good catch of my error before I went too far. So that actually should have been 3/4. And then I'm going to use inverse tangent of negative 3/4. And I come up with negative 0.6435. Now, this is not the angle in the region I'm looking for. That's actually in quadrant 4. But I'm going to start with that angle anyways, and then I'll sort of work my way. So this is one of my possible solutions. And I'm going to need to set, and then, no, never mind. Let me undo that. That is the wrong way to describe this. This is not one of my possible solutions. It's not in the interval. Also, this is one of the possible values that would get put in here for this whole sort of 2x value. So 2x could equal that negative 0.6435. But that's not actually what I'm looking for. I'm looking for the value of x. So I would need to take this a step further. Unlike the previous problem where I just had x in there, I need to do this extra step. And so I would divide by 2 and I would get that negative 0.322. But this still isn't in my interval because I'm looking between 0 and 2 pi. But tangent tangent here has a period of if I could sort of pi over 2. And so I could figure out my next solution by adding pi over 2 to this. And that would get me sort of my next solution along the way. I could add pi over 2 again, and I would get my next solution. That's one way to look at it. Because every pi over 2, we're going to have a new period come along. Tangent's sort of unique in that way where I don't have to necessarily set up my second angle because you have multiple periods within one trip around the unit circle, and that's why you get the multiple solutions. So if I keep adding that period of pi over 2, I would end up with the solutions of 1.249, 2.820, 4.391, and 5.961. So 4 solutions. If I added pi over 2 again, I'd be outside of my domain that I'm focused on. But yes, and so tangents a little tricky with that, but still possible, still sort of similar ideas to when we had, an inner function when we were dealing with some sine and cosine functions in the last unit. Now, our next 4 problems, you'll notice that we have our reciprocal functions. So yes, it is possible to solve equations with the reciprocal functions there. Personally, I prefer to turn it into sine, cosine, or tangent. I'm more comfortable using inverse in those situations. Though if I'm double checking my answers, I would go back and graph the original equation, just in case I messed up on my algebra anywhere along the way. So in this case, I want to get rid of that 1/2, so I'm going to multiply by 2. So I have cotangent of x equals -10. Now, if cotangent equals -10, tangent of x, the reciprocal function, would equal -1/10. So, it's a quick shift into that reciprocal function, which we then can take the inverse tangent to find the angle measure. And I would end up with -0.0997. And since we don't have a, b value here, our period is just pi. So if I add pi to this, I'm going to get into my first solution, which is at 3.042. And then if I add pi again, I would get my second solution of 6.184. And so I have my 2 solutions. Woohoo. All right, the next one, secant. So I'm going to divide by 3. So I have secant of x equals 2/3. And so then I would say, all right, secant is the reciprocal of cosine of x. So cosine of x equals 3/2. And then I go, oh, there's a problem here, because cosine of x cannot be greater than 1. Yet this is saying cosine would be equal to basically 1.5. So this would not actually be possible. There is no solution. And that's because cosine can't be greater than 1. And secant has to fall basically between, it has to be either smaller than -1 or greater than 1. And so it can never actually equal 2/3. So there's no solution because, secant of x would need to either be greater than or equal to 1, or secant of x needs to be less than or equal to -1, but can't equal 2/3. All right, so we had a no solution one. Now let's hope the next few have solutions. So we're back to secant again. 1/4 secant of x equals -2. So I'm going to multiply by 4 to undo that 1/4. So I have secant of x equals -8. So the reciprocal of secant, remember, is cosine. And so cosine equals -1/8. So we're going to use inverse cosine here. So inverse cosine of -1/8 gives us 1.696. So if it helps to draw a picture, there's my first angle. Its matching pair should be down here in quadrant 3. So to figure out that angle measure, I like to do 2 pi minus 1.696, which would get me 4.587. All right. Similarly, but this time with cosecant, we have a 3 here. Cosecant of x equals 2. Cosecant is the reciprocal of sine. So sine of x equals 1/2. Now, this actually happens to be a trig value that comes up with some exact measures. And this is, sometimes people actually have this value memorized. But it is pi over 6. If you put it in your calculator, you might get 0.524. And then, so if you're thinking about sine, so we had a value over here. Its matching pair would be in quadrant 2, which would be the angle 5 pi over 6, which is 2.618. And you could have figured that out by doing pi minus pi over 6. Would help me figure out that second angle using our sort of symmetry and reference angles. All right, and that is the end of Module 10's CYU. Hopefully these explanations help you better understand the problems.